that there is actually a fourth dimension. So all dimensions.
Have you ever worked with or been to Hadron Collider?
A multi-dimensional universe, and there's at least 11 dimensions.
Meet Max Laughlin, a child prodigy whose astonishing claims have rocked the world of science. He insists that in 2022, CERN, the European Organization for Nuclear Research, opened a gateway to an alternate dimension. But what's the evidence behind this jaw-dropping assertion? Let's find out. On July 7, 2022 at 5:18 a.m., a phenomenon occurred that left scientists baffled. A mysterious crack in Earth's magnetic field. This enigmatic tear remained open for a whopping 14 hours, allowing solar winds to wreak havoc on our planet's magnetic field. But what caused this otherworldly tear in the fabric of space-time? Scientists linked the strange event to a rare solar happening called a corrotating interaction region, CIR. It's when solar winds clash and create massive plasma formations that can damage our magnetic shield. But is this enough to explain the extraordinary events that followed? Interestingly, at the same time, 3 new exotic particles were found at the Geneva Collider. This included a brand new Peter quark and the first ever tetrax. It left scientists amazed and expanded our knowledge of particle physics. Now, let's talk about the Large Hadron Collider itself. The Large Hadron Collider, LHC, is the world's largest and most powerful particle accelerator, located beneath the Franco-Swiss border near Geneva, Switzerland. It was built to explore fundamental questions in physics by smashing subatomic particles at nearly the speed of light. It is considered safe, but imagine if we live in a world where matter behaves in strange ways. Quantum mechanics suggests particles exist in multiple places at once and defy time and space constraints. So, how can researchers at CERN claim that particles from their experiments aren't spilling into other dimensions? Well, officially, CERN's discoveries include 70 new hadrons, those tiny subatomic particles held together by the strong nuclear force. But here's where the controversy begins. Critics argue that CERN might be conducting experiments far more extensive and secretive than what's publicly known. And that's where the real concern lies. There have been whispers about CERN trying to create black holes, possibly unintentionally, or even opening gates to other dimensions beyond our control. Now, here comes a shocking warning from an extraordinary child, Max Laughlin. This young prodigy possesses an extensive knowledge of quantum physics and the nature of our reality. In a video, he boldly claimed that CERN had destroyed the old universe when it resumed operations in April 2022. According to Max, there was an original timeline, but thanks to the experiment, an anomaly occurred, catapulting us into an infinite number of parallel universes. Quantum physics hints at such possibilities, as seen in experiments like Schrödinger's cat and Wigner's friend, where we navigate through multiple universes with our decisions and consciousness. Max, however, believes these experiments have collectively shifted humanity and our planet into another dimension, one most of us remain blissfully unaware of. But the Large Hadron Collider can't create black holes due to limits. Some minor space-time quirks, like black holes, have been observed, causing protests. Some want to shut down the collider due to strange events and concerns. But many experts support it. They're trying to find a mysterious fifth force of nature, a big deal in physics. Critics say they're tampering with unknown consequences deep underground. This revolutionary marvel took 2 decades to build and was met with its fair share of protests and criticism. More than 10,000 international scientists from hundreds of universities and institutions across 100 countries were involved in this colossal project. It's located between 100 and 175 meters beneath the Earth's surface, right under residential areas, supermarkets, kindergartens, and roads. Many ordinary people in Geneva were understandably concerned about their safety, despite petitions and complaints. Picture this. Superconducting magnets and specialized acceleration structures work in tandem to massively boost the energy of particles. Two beams of these tiny particles whiz around this massive ring, one clockwise and the other counterclockwise, reaching speeds close to the speed of light. But the particles collide, and it's in these ultra-fast collisions that they become measurable. They interact with each other, breaking down into even smaller particles. These smaller than small particles we're talking about are the building blocks of our universe, like quarks and gluons. Quarks, these subatomic particles, are incredibly unstable, often disintegrating in a fraction of a second. Meanwhile, gluons, the mediating force, are the glue holding it all together. And the collision? Well, it's not a secret rendezvous. It's meticulously detected by detectors inside the accelerator. And all that complex data is swiftly sent to a network of supercharged computer systems. From this data, researchers hope to uncover the mysteries of particles that exist far below the threshold of visibility. You see, no human eye has ever gazed upon a lone photon or electron, not even once. Our knowledge of these particles comes from the effects and behaviors they exhibit. The story of the Large Hadron Collider, LHC, begins with its first ever collision, happening 2 years after the completion of this massive machine in 2010. Before that, scientists conducted similar experiments at an earlier facility, but it pales in comparison. The prototype was far less energetic. The 2010 tests were conducted at a combined energy level of 7 tera-electron volts, nearly 4 times higher than any previous series of tests. But even then, it wasn't enough. We needed to delve deeper into even smaller particles. That's where upgrades came into play, ramping up the intensity to a whopping 13 tera-electron volts. This extra juice allowed the LHC to produce an even more intense collision, revealing the secrets hidden within. Now, here's where it gets even more fascinating. In 2018, the LHC was unexpectedly shut down. Local residents couldn't help but link this shutdown to a bizarre weather phenomenon that had swept over Geneva during the summer. People across Switzerland and neighboring regions in Germany and France reported peculiar happenings, and seismologists recorded an uptick in smaller earthquakes. But officially, they say these events had nothing to do with the facility's shutdown. For 2 long years, the LHC remained dormant, silent. Then, in 2021, it roared back to life. This time, it embarked on test runs with a maximum beam energy of 6.8 tera-electron volts per beam. The new full test series at the LHC is expected to run until 2025, and believe us, it's nothing short of astonishing. Now let's talk about the infamous Higgs boson, also known as the God particle. Over the years, the LHC has tackled some major mysteries. Before the epic collision in 2012, the Higgs boson was nothing more than a theoretical concept. Despite numerous experiments, researchers couldn't lay their hands on it. But after several upgrades to the LHC, they finally struck gold and detected the elusive Higgs boson. During this series of tests, scientists were on a quest for more knowledge, including delving into the enigmatic world of dark matter and ghostly particles called neutrinos. Neutrinos are like electrons, but with a twist. They have no electric charge and originate in the depths of stars. Dark matter and neutrinos are some of the most puzzling elements of our universe, and the LHC is on a mission to unravel their secrets. Now, let's get down to the nitty-gritty of the Higgs mechanism. This theoretical concept explains how particles gain mass. Picture this. The Higgs field is like an invisible web that permeates all of space. It's the magician behind the scenes, granting mass to other elementary particles as they move through it. Without the Higgs field, particles like quarks and electrons would be massless and zip through space at the speed of light with no form or substance. This field is fundamental in shaping the matter around us, making it a cornerstone of our universe. The big reveal came in 2012 when the discovery of the Higgs boson was announced. It was a monumental victory for particle physics. Back then, the media couldn't stop talking about the God particle. But as incredible as the Higgs boson discovery was, there's something even stranger. Strangelets. Strangelets are hypothetical exotic matter objects composed of strange quarks, one of the 6 types of quarks, which are the building blocks of hadrons, protons, and neutrons. Unlike the light up and down quarks that make up everyday matter, strange quarks are heavier and more unstable. The intriguing idea here is that strangelets could be a collection of stable strange quarks formed when sufficient energy is applied to keep them together. They might also come into being during the high-energy particle collisions at the LHC. What sets strangelets apart is their remarkable stability compared to normal matter. Now, here's where the controversy starts to heat up. There are speculations that once a strangelet is formed, it could act as a catalyst, transforming ordinary matter into strange matter. This has raised significant concerns. Some experts have suggested that if a strangelet were to escape from the LHC's experimental facilities in Geneva, it could potentially jeopardize the stability of the entire universe. It's a situation shrouded in unpredictability, the very essence of strange. But here's the twist. CERN doesn't seem to be losing sleep over it. In fact, they're planning to boost the collision energy and upgrade the detectors to keep probing deeper into the unknown. Now it's your turn to weigh in. Is this bold science, or have we crossed the line into madness? Share your thoughts in the comments below, and don't forget to hit that like button if you've enjoyed this video.